Hello and welcome to another session of Me Programming Daily. Today on the agenda, I would like to implement the fork parser, or the part of the parser that parses fork strings, if that makes any sense. We can already parse actions and questions. The natural consequence is to add the ability to also parse forks in the user input. And user input today looks like so. It's a very simple parse, and I just needed to be able to more freely experiment with different types of input. So it is not supposed to be rocket science. It's not supposed to be too advanced. Maybe it will become more advanced as time progresses, but for now, I'm perfectly happy with it. So a quick refresher, the fork type or the skewer block type, where fork is one of the data constructors, looks like so. Fork can contain fork should contain two lists of skewer blocks, but these lists could be empty. So why don't we dive right into it? I'm planning today's session to be rather short, so we'll see where this takes us. I hope you have your coffee or whatever the drink of your choice could be ready, and let's get to programming. Should I address these warnings to begin with? Let's address at least one. Redundant bracket in line 212. Three hints. Maybe let's address another one. This was pretty easy to fix. Maybe another one. 209. Oh, it's these ones. Okay. I think we can just remove all these. This one is actually a very good suggestion. We never match for empty strings, but this is easy to fix. And also, Let's reuse the same line here. And also line 292. Right, this collection is expected to be empty anyway. Oh yeah, and let's also remove that error shadow. 3, 4, 5. So I ended up fixing all warnings. Or most of them at least. 288. Two, 7, 9. Two, 7, 7. This origin is not needed. Beautiful. I know that I'm probably not supposed to be on one branch for that long, but I suppose we're still experimenting. All right, where were we? Fork. So for now, let's just prepare. Let's just render. Well, let's just prepare for rendering a fork. It's not going to be completely correct, but that will have to do. Question cannot be defined like that on its own. So here, let's define a fork. Yeah, this already rendered. So we have what? Title, correct, action. I'm looking at this. Fork. And fork has an action and a question because we hard-coded it, not because it's provided in the input. The input is empty. Then we have an action, question, action, and end. Okay, so this is working fine. Let's leave this on the side as a visual aid. And here, Let's try to start parsing forks. So here are just collections of skewer blocks, which we finished yesterday. So we'll have to implement something here. Something like that. The indentation is probably botched, but it's fine. So here is the collection of left skewer blocks with the remaining tokens. And now, oops. We need to parse the right-hand side collection. We can sort of reuse this. My indentation is so wonky because I intend to leave the heavy lifting of formatting to H-lint or H-format. Forgot what we were using. H-indent. Okay. So now we want our skewer blocks with the new residue tokens, or remaining tokens. And here we are returning our skewer blocks and L. So it does build. Success. Let's format it. Let's take a sneak peek how it looks like formatted. Okay, not too bad. So now what we need to do because we hard-coded the rendering to fork containing an action and a question, let's flip that order. And let's start with question. The second one should be action. So if this works well, these shapes should be flipped around, and they are. Question action. Okay, so it wasn't that hard. So now let's do something crazier. And let's introduce a number of shapes. Now, this is a little bit harder to read. So it's functional, I can use it, but it's probably not the best. Let's see. If I can introduce another fork in here that contains one action on the left and say 6 actions on the right. Oops. What did I do? Okay. Okay, so this is a little bit harder to work with, but let's see if it does work. So first fork has 3 actions on the left and 2 actions on the right with a fork. 3 actions, 2 actions with a fork. Fork number 2 has 1 action on the left, correct, and 6 actions on the right. 1, 2, 3, 4, 5, 6. Beautiful. Okay, so I think this is really good. Even if I do say so myself. So yeah, I think a short session today. I've just introduced the fork parser, or the fork section of the parser. For a while, I thought it would be a good idea to give these bounding boxes also background. But let's maybe experiment with that. If we give those bounding boxes a background, it will be a little bit easier to visually inspect them, or visually inspect the diagram if we want to troubleshoot it. So let's introduce something like background color. And let's make it, say, light gray. So 10, oh no, sorry, that's the other way around. 200, 200, 200. So the background color will be reserved for, say, a fork. And let's take a look where this color is defined. Foreground color. I probably don't import it yet. I hope we don't paint over the actual blocks. I'm not seeing any difference. Oh yeah, so there needs to be a shape for that to work. I think, is that right? BG. It's not perfect, but it does the job. So I was thinking to increase the tone or modify the tone as we progress down the recursive data types. So we could start with white. The first nested, say, action, we could use very light gray, then darker gray, darker gray, darker gray. But I'm not really sure how to do it, and even if I want to do it in the first place. It's just a cool experiment to have. For now, though, let's just leave it as it is and wrap the session up for today. And the next session, I think what I'm going to try and tackle is connections visually rendered between skewer blocks and terminators. Let's see how that goes. I hope this will be interesting. In the meantime, I thank you very much for your attention and have a great day. Bye.